welcome to the Deep Dive. Today we're jumping straight into the world of data storage and database design.
Yeah, it's all about how data gets organized, managed,
Yeah,
the fundamentals.
exactly. We've looked at sources covering storage types, ODS, data warehouses, data lakes, that kind of thing.
Right, and also relational databases, tables, keys, normalization.
The building blocks. Plus models and schemas. Our mission, cut through the jargon, give you the core ideas fast.
Make it clear how it all connects, basically.
Okay, let's dive in. Where does all this data actually live? First up, the ODS, Operational Data Store. What's that about?
Think of an ODS as like a temporary holding spot. It's for current transactional data.
So very up-to-the-minute stuff.
Yeah, constantly getting updated, overwritten. It really supports the day-to-day operations directly.
Got it. Then there's the data warehouse. Sounds bigger, more permanent.
It is. A data warehouse collects data from many different sources over time. It's built specifically for reporting and analysis.
Ah, so looking for patterns, trends, that sort of thing.
Precisely, getting that holistic view.
And a data mart, is that just a smaller warehouse?
Kind of. It's usually a slice of a data warehouse tailored for a specific department, like, say, marketing or sales.
Okay, so targeted information for specific teams. Makes sense.
Yep, draws just the relevant data they need.
Now, the data lake, that sounds different.
It really is. Unlike a warehouse, a data lake stores data in its raw format. Structured, unstructured, semi-structured, everything.
So no predefined schema when it goes in.
Exactly. It's like a vast pool of raw information, great for exploration, maybe finding unexpected insights later.
Interesting. And briefly, where is this stuff physically stored? On-premise or cloud?
Well, there's definitely been a big shift towards the cloud.
Why is that?
Mostly scalability and often cost. With the huge amounts of data businesses generate now, the cloud offers flexibility that's hard to match on premises.
Right. Pay for what you use, scale up or down. Okay. So we have these storage options. How do we actually structure the data inside them? Let's talk relational databases.
Sure, relational databases are sort of the foundation for a lot of structured data storage. They're really efficient.
What are the main benefits?
Well, the big goals are completeness, no redundancy, aiming for that one version of the truth.
Ah, avoiding confounding info.
Exactly. Plus, they help enforce business rules and just improve communication because everyone's working from the same consistent data.
So how are they built? What are the core components?
It starts with tables. Think of a table as holding information about one type of thing, like customers or products.
Okay, entities.
Right. Then tables have columns, which are the attributes like name or price,
Attributes, got it.
and rows, which represent the individual records, so one specific customer or one specific product.
And you mentioned keys earlier. How do they fit in?
Keys are crucial. You have a primary key that's a unique identifier for each row in that table.
Like an order ID or a social security number?
Exactly, something guaranteed unique. Then you have foreign keys. A foreign key is a column in one table that points to the primary key in another table. That's how you create relationships.
Ah, linking things together. Like
Yeah.
the customer ID in an orders table links back to the main customer's table.
Precisely that. That's the relational part. We also need to define data types for columns, right? Like text, number, date.
Yeah, that tells the database how to store it and what you can do with it later, analytically.
Exactly. So you need a way to keep track of all this structure, what everything means.
Which brings us to the data dictionary.
Right. It's essentially metadata data about your data.
Okay, like a guidebook.
Yeah, it defines every table, every column, its data type, maybe business rules associated with it. Absolutely essential so people use the data correctly.
Avoid misinterpretation. Good point. Now, what about redundancy? You mentioned databases aim to avoid it. That's where normalization comes in.
Yes. Normalization is the process of organizing the columns and tables to minimize that data redundancy.
Tidying up, basically.
Sort of, yeah. It also helps prevent data anomalies like update issues or deletion problems. The goal is often summed up as ensuring attributes depend on the key, the whole key, and nothing but the key.
The whole key and nothing but the key. Okay, I hear about different forms, 1NF, 2NF, 3NF.
Right, those are levels of normalization. First, normal form, 1NF, is basic unique primary key, no repeating groups. Second, 2NF builds on that, ensuring non-key fields depend on the entire primary key.
Okay.
And third normal form, 3NF, goes further, making sure non-key fields only depend on the primary key, not on other non-key fields.
So progressively stricter rules to reduce redundancy. Got it. How do we even plan all this out before building?
That's where data models are essential. You typically start high level with a conceptual model, just the main entities and relationships, very business focused.
Like a rough sketch.
Exactly. Then you develop a logical model. This adds more detailed attributes for each entity, primary and foreign keys. Still technology agnostic, though.
More detail, but not tied to a specific database system yet.
Right. Finally, the physical model gets specific. It maps the logical model to an actual database system, defines data types precisely, indexing all the implementation details. This directly informs the data dictionary.
Conceptual, logical, physical.
Increasing detail. Okay. And lastly, database schemas, like Star and Snowflake. Where do they fit?
Those are common ways to organize data specifically within data warehouses and data marts, optimized for querying and reporting.
How do they work?
They generally involve fact tables and dimension tables. Fact tables hold the core measurements or metrics like sales amounts, quantity sold.
The numbers.
Yeah. And dimension tables provide the context who, what, where, when. Think customers, products, time.
Okay, facts and context. So the Star schema.
That's the simplest. You have a central fact table directly connected to several dimension tables. Looks like a star. Easy to understand.
Makes sense. And Snowflake.
Snowflake takes the star schema and normalizes the dimension tables further. So a dimension table might link out to other tables.
Breaking dimensions down even more. Right, it reduces redundancy more, but can make queries a bit more complex. It's a trade-off. Both work well with business intelligence tools.
Star for simplicity, Snowflake for more normalization. Interesting. Wow, we covered a lot there.
We did, from the different places data lives, like lakes and warehouses, to how we structure it with tables and keys, keep it clean with normalization, and plan it all with models and schemas.
It really shows how much thought goes into organizing data effectively. So here's something to think about. Knowing all this underlying structure, the models, the schemas, the normalization, how does that change how you view the information you rely on every day? What questions pop up about the data shaping your world?
Good question to ponder.
Thanks for joining us on this deep dive.